really helped in the essence of having to interact with people, sharing knowledge. Sometimes I think it was the other man that was talking yesterday that you never know that he was telling us to ask for each other's name. It's not just even just about the name. In the process of interacting, you actually discover that it's a symbiotic relationship. There are some knowledge you think you have when someone else comes and gives you another point of view, it expands, your horizon. So I expect much more than that today. Thank you very much.
Good morning, everyone. My name is Engineer Benga Olukide. I'm from Energy Commission of Nigeria. Actually, my agency happens to be one handling the industrial energy efficiency component of this project. I was here yesterday, and what I saw here yesterday beat my imagination, despite being on the project, but I saw a different perspective to that project via the presentations of the presenters yesterday. So I think is a good thing. And today I'm expecting much more better than that of yesterday. It has been an impactful program, training program, really. Thank you, everyone.
Good morning. My name remains Joseph Abaume Adeogun. Since yesterday, I've overwhelmed by knowledge I've acquired here. I'm a technician, but with the level of things we've contributed here, I know how to put up myself together in the area of trade I'm doing so that I can be more better off yesterday. Thank you.
Good morning, everyone. My name is Michael. The program yesterday, it was eye-opening. I really learned a lot from the training, from the exercises today. It really impact more knowledge into me because when you interact with people, from there you learn more things you don't know. You use it in future to help yourself and the economic you are serving. I look forward to see more in today's program. Thank you very much.
Good morning, all. My name is Uchenna Madbuko. Yesterday was a very interesting meeting. I learned a lot, especially on the area of the group discussion, the insights, the knowledge, the expansion of the program, the wisdom, especially on the RECP policies that organization can achieve a balanced economic growth and environmental stewardship. So by today's own, I still believing to expand my knowledge and wisdom. So thank you.
Good morning. My name is Emmanuel Ako from CAP Cooperative Society. Yesterday's lecture was very helpful to me because I learned about waste valorization. That's converting waste product into meaningful byproducts for our use. Thank you.
Yeah, good morning, everyone. I I want to say a very big thank you to the organizer of this training. My name is Peter Antoniano Sike, mass furniture. I'm into furniture production. Yesterday was a very good day for me. As someone who produces something, and what we do, we need light to do it because we use a lot of machines. So yesterday I came to understand that there are a lot of things that we've been doing that we're not doing right. And with the training that I had yesterday and the one that we're going to do today, I know when I go back to the company, we'll be able to do things and do things right. Yesterday when we were talking about the waste products. I can't understand that so many things that we've been throwing away. Yeah, it's actually something that would have been giving us money. And wasting energy. The training was just so impactful, and I'm grateful. Thank you very much.
Good morning, everyone. My name is Oyede Winga from Nigerian Environmental Society. For me, I saw yesterday that this is like a melting point for both resource users and conservationists. So coming here, they shed more light on the use of resources and having it. So today, I expect to see more of those methods to achieve sustainability. Thank you.
Good morning, all. My name is Musa Murtalano from Federal Ministry of Environment. Actually, yesterday's lecture was more of my field because Daddy talked on environment, actually the greenhouse gases, the clean development mechanism, and what have you. So at least I enjoy it so much, and from the energy perspective, it was very interesting. I'm looking forward to getting more today. Thank you.
Good morning, everyone. Uh, Regarding the lectures we had yesterday, I think it has changed my overall perceptions as regards to energy conservation and uh, uh, efficient way we can manage our energy consumption. And it also made me think twice when when it involves this waste generation. I came to realize that we don't have anything like waste. But to the extent that I used to ask myself, does waste exist? I believe that ignorance exists, but waste does not exist. Thank you.
Good morning, everybody. My name is Daniel Ibobo. Like I said yesterday that I was going to learn new things. I actually did learn a lot of new things. What really stood out for me was this statement the second facilitator kept saying that one man's waste is another man's raw material. That thing really sunk deep into me, and I think we are going to really explore on that to know that some of the things we used to throw away could be converted to useful things. Thank you.
Good morning, everybody. Yes, actually, from what we have learned yesterday, we come to understand that the importance of reducing CO2 emissions resulting from industrial use of energy, and and also the need for efficient use of energy. And I hope everybody will understand better and extend same. Yeah, thank you so much.
Good morning, everybody. My name is Ibidoni Annette Roberts. I'm from IBY Roberts and Company Limited. We are into cosmetics and food. In our cosmetics, I learned yesterday, what I've been doing is like I got an encouragement. I use waste, what you call waste from other products to make my cosmetics. This is soap made from cocoa pod. So, and when the presenter yesterday was talking about that, I was very happy that at least this is something in the line of what I was doing, and then I got an encouragement to do better. And I also learned also about this energy management, for sufficient use in my industry, though we are still small. So even as we grow, we can incorporate all this knowledge so that as we move on, we'll be doing the right thing along the value chain. Thank you.
Hello, good morning. My name is Khadija Oladipo. I'm from Federal Ministry of Environment. I work with the RECP Technical Working Group. The lectures yesterday, we've been having some of those, but to keep having them is important so that we keep reminding ourselves and others about the importance of RECP and energy efficiency. So it's good to gain more knowledge and also share knowledge. Thank you.
Good morning, everyone. My name is Olaruwa Falabi from Qualiwire and Cables. Yes, this lecture will be nothing short of an eye opener to the importance of our environment and also the benefits of efficient energy measurement and use.
Good morning, everyone. My name is Ophel Shigladis from Kwali Wires and Cable Manufacturing Limited. Yesterday's lectures was an eye-opener to me. When I get home yesterday, I started correcting some things. That light, you are not using it. Why is it on? That freeze, I even reset my deep freezer yesterday. Thank you. So I'm expecting to learn more today. Thank you very much.
Good morning. I'm Comrade Abdurrahman Abdusalam from Qualifier Production Manager. Well, yesterday, another good day for me. It's an added advantage to my experience because we value our waste ever before. So we are going to improve on it more and more. Then as for the environment, yes, there are a lot I picked from that place. So I think we'll add more advantage to it today. But however, we can't just continue praising without measuring some observation. Well, the organization tried a lot. They have done a nice work in organizing this seminar. But I still hope when next I come here, I will not be going with my hand out, holding it at hand, dropping items along the line. I think there should be a little bag for us to keep our hand out. Thank you very much.
Good morning, everyone. My name is Mr. Kelechi Obina from Nezra. As I'm from Nezra, yesterday's presentations, they were very, very informative and very, very good, especially in the area of managing waste and using waste as somebody's raw materials. Because Nezra, obviously, we are very concerned about waste. So it's a very good waste management strategy to, if several companies can meet each other, say, oh, what raw material do you need? Oh, those raw material you need, we actually throw them away because we don't need them. So if people can come together and work with each other, I believe it can be a fruitful and very, very profitable way of managing waste in the country. And also the management of energy, the efficient way of managing energy. It was a very, very good lecture, and it's provided a very good insight to how wastage is being carried on by companies and individuals. So I hope to learn more today on it. Thank you.
Good morning, all. I'm Engineer Victoria Ifyong. I'm from NESRA, National Environmental Standards and Regulation Enforcement Agency, from the Inspection and Enforcement Department. Actually, I'm the Chief Engineer, and I'm working with the food and beverage sector. So, when we talk about yesterday's lectures, the RECP was very, very interesting for me because that's my field. I practice it almost every time when I go for industrial compliance monitoring. I look at the resources that flow from the process line from the beginning to the end. But I've never paid attention to energy. So because of this training now, I know that when I go next time,
I will start with energy, continue with resource with the process line, and combine the energy together, and then discuss with the industries on what to do, because obviously I know we'll discover something they need to do and improve on. Thank you very much, sir.
Good morning, everybody. I think I came in yesterday without even knowing what the training is all about. Until getting here, I saw it on the banner. But when everything started, it was like it was more than a training to me. It was just like eye opener, and also that trying to show things that that. In fact, when my first month in the enablement, one thing I started was to see how to reduce some of the energy consumption, because getting to the offices, the hall, I saw a lot of things. I started it getting to a point that the financial manager have to say, but this bulb, they are not dead. Why not we leave them until we're dead? And I say, okay, maybe to them, it's not really anything to them. But this training has opened my eyes to know that it might not mean anything to the company, but it mean anything to the environment, and it mean anything to the country himself. So to this, if I go back now, I have to now sit down. Now I have answer to give to answer. I mean, I have answer to those questions again, to those challenges. I have to now start them down. Now let them know that it might not mean anything to them, but it mean anything to the country. It mean anything to other people. And I will look forward to see that man is really doing a good job. Only an association industry, maybe in addition, I will just be looking at how to make profits. But they are also concerned about the country himself. I think in my days in school, we were taught about small industries that are attached to, they are very close to bigger industries, just to what? To make use of their waste product and other things. And those small company or industries, not only that they are making profits, but to make the environment what? Better. And I know somebody was complaining. I was with somebody. Is participating in one of. I mean, is having one of these small. Company. But the complaint is that tax from government, and we have government agency here that's dealing with the environmental. Company like this supposed to be tax free, and encourage them to do more, so that with this we'll see that we'll be able to make the country a better place to be. So I think this training should be more, not only the for industry, the government agency also needs to be trained very well, because sometimes you just see as if is it that they don't know what are they there to do, or they just feel like reluctant to do what they're supposed to do. But if this training got to them and the government itself, I think things will be done better and we'll have a better country.
Good morning, all. My name is Domina from Abumet, Nigeria Limited, HSC team lead. Yesterday training, I will say that I really learned a lot from yesterday training. I've been able to understand how to manage energy. The practical demonstration we did yesterday, how we can control the waste energy, we manage it from one station to the other. Not only that, for our RECP, it was an eye-opener to me, because I come to realize that we can actually trade carbon dioxide in international market.
There is a graph on that here. This graph is what shows what I mean. So let's say here I have it was 3 here, and I make, let's say I make 5 here. So the picture has changed. Okay, let me make leadership for example. Let me use leadership as example, because now it seems to think about that. But let me show you the first one that we have seen. See the first one that we have seen. Can you see it? Is it clear? Yes. Okay. Okay, let's see. So let's see leadership. Leadership is zero now. So let's see why did we pick zero here. So the zero comes. So zero is not part of the picture that we're looking at. So let's go to leadership. You see leadership here as eight. So you see personnel feel responsible for energy and continuous improvement regular. If there is a personnel that you have identified, big five. Don't forget, this is fine. So this is fine again. Do we see the fine? Do we see the fine? Yes. So okay, let me do something. Let me try to. So now, do you see now? So now, based on this now, I can say, okay, for the leadership, if they have systematic, sustainable leadership, by example, I can pick this five. Okay, I get there. What they practice there is they just manage the system. They have bottom or energy leadership together with the top down level. I will pick four. Am I communicating? Yes. So okay, that continues until so now let's now say, that was zero for leadership then. So let's now say, when I go to this side, I feel like, no, it's not like this. What I got here is four. So you come here, put four in here. Then you get outside of the cell, then you come to the leadership. See, the leadership is now as 4 0. You understand what I'm saying? So, you not okay, let me call it again. I will use another example. So this is investment. This is the radar for investment. This is the radar for energy policy. This is the radar for organization, and so on and so forth. Are we together? Now, for investment now, when we go to the site, you want to know what exactly happened with the investment. So what I'll do is, okay, investment, let me look at what are the things associated with investments and how I can grade them. Okay, they have positive discrimination in favor of green schemes. It's detailed list of all opportunities. If they have it, you make five. This is fine, yeah? Okay, so now, if they have same payback criteria is used for all investments. All this is just like you want to know the culture of the organization when you are there. What are the things that are in place? Okay, what are the things that can help manage the energy? You agree with me that no matter what you know as a technical expert, if your boss says no, it is no. Am I communicating? So the thing is, when you are implementing this, you want to capture every factor that will be responsible either to the success or to the failure of what you are doing. So it is a system that is in place. Okay, so now, okay. No, this is a template that you will have. I was saying it yesterday. I said we have like experts of more than 10 years of experience. Do you remember me saying something like that yesterday? So I was saying they came about to bring this tool. It is a tool that is to help individual that is practicing or that want to implement energy management system to be able to achieve that. Okay, great. Thanks. So now let's say when I go to the facility, they have this kind of positive discrimination in favor of green scheme, for example. Don't forget, let's check what did they pick. They picked two before. So let's see the two in investments. See investment here. Have you seen investment here? And it is two here. Do you see that? So if I come here and I say, it should be 5 in my facility now, which means they have positive discrimination in favor of green schemes. So that means I will come here, I will score them a 5. Does that make sense? So after you type 5, you click outside, then let's go and check. Investment is now 5. Do you understand? So this is to keep track. When external, because
If you want to certify any company with ISO 50001 certification, you have to present all these documents. We share it to them that these are the things, these are the conformities that you have seen, these are the non-conformities that you have seen. So with these two, you'll be able to gather all the non-conformities. Do we understand? Okay, great. That's the first page. So actually everything, it covers from energy policy, organization, energy organization structure, energy managers readiness. When you get there, are they, okay, what do they have in place? Oh, they are professional energy managers. You give them a 5. Oh, they are energy managers. They receive regular and specific training on energy management. You know, there are different instances. You give them a 4.
Do we get it? Yes.
If they have more than one, what happens? If they have this and they have that. If they have 5 and they have 4, what happens?
So if they have 5 and they have 4, you give preference to the 5 because the one that has the or let me say the one that has more say. If the person that has more say is the person with the certified energy manager, as a certified energy manager, for example, you will give him the preference that is the in charge. But in case he's not the one, you may want to know why, what happened, and whatever. But the right thing is to give the number 4. If number 4 is there and is the one in charge. Do we understand? Okay. So thank you for the question. So the next thing is it goes from other personnel. Are they ready? Is it like when it speaks, they feel like, no, who are you talking here? So you have to score them too. I want to believe you understand this page now. Okay, let's go to the next page. So commitment 2. Want to check what are the barriers that they can have. So now, available human resources or time to manage ENMS, whatever. Do they have the time? Do they consider it needful? Like, what is their opinion about it? If you have anything about the evidence to show for that, you can type your evidence here. Oh, when I got to the facility, the human resource is poor. They don't really take energy efficiency serious. We can put it at the evidence level. Like, okay, you can put it there that if you have anything to prove for it, let's say there are male that supports that everybody should comply to energy. That's an evidence here. I don't know if you understand what I'm saying. Okay, so if there is any countermeasure, you want to put it here. If there is any forces for change, you have to put it here. As you observe when you get to the facility. Do we understand? And you can also use it for your own facility. So one of the things that we would expect from you is that you will feel this yourself. And then we will get, there will be a place where you impute the data of your consumption, everything. We'll still get there. So at that point, it will help us to understand what happens in your facility prior to visiting your facility. Do you understand that? Okay. So do they lack energy management system knowledge? Do they don't know anything about energy management? You want to write anything about that here? If you have evidence for that, put it there. If you don't have evidence, no evidence. Okay? So you want to know if they lack documented culture. All this. I want to believe you understand this part too now. Or because I'm looking at our time actually. Do we understand or I should still continue? Huh? Okay. So let's say we have 5-year plan, the life cycle cost evaluation. Okay. What's their perspective about it? Like, what do they have to show like, okay, they have this life cycle cost analysis, a lot of other things that they do in their facility. You want to know if they have any countermeasure towards it. Oh, energy management in this facility should be great. And then you find out that some people believe that, if they now come and check our energy consumption now, it will be like we'll not have money to buy diesel again to our pockets. A lot of things happen when you visit. And one of the challenges you may actually also have is, as an energy expert, is when you are visiting a site and those guys are looking at you from the perspective that you want to come and expose them. You know, that is a big problem. You tell them, I want to help you cut your energy cost. But the energy cost is not as much as they are presenting to the management. You coming around, you see the consumption, they feel like this guy will come and just destroy our phone here. You know, it's a serious challenge. So the next thing is, in many situations when you speak with the technical person and they are not conforming because they feel like, you say, oh, I want to talk, can we know more about energy? Do you know anything about energy management? Don't bring that rubbish here. You know, they do that thing here. You know that one. So there's no problem. You put it as part of concerns. Okay. But not really like you're trying to expose them, but you know, the goal of this is to understand how accurate your data is. If we believe that in facilities where they give you open hands, of course you have reliable data from where they are trying to hoard information. So this will give you a very good and make you to make good judgment when you are. Okay, so let's go to this tab. We have here, you may want to look at the political, the PESU, the political, the economical, social, technology, legal, environmental. Oh, this is an airport. You want to implement, let's say you want to even introduce solar system to them. Oh, we don't want solar on our roof. Why? It will flash light to aircraft when they are coming. You are coming to put it here under environmental, like the environment is not favorable to that. Do you understand? Oh, it is economy that is not that is affecting. For example, there was a time I was privileged to go and do a walk like that in Ghana of recent, and I found out that solar cost there is crazily expensive. Solar panels. Like for example, if you look at the solar panels that you said they sell it around, let's say 120, 130, the equivalent of that same capacity in Ghana can be around 220, 250. Is that high? No, that is economical issue. Do we understand? Oh, there is a news of recent that some people thought what was chasing rain away from their facility was solar panel. Well, and they started destroying the solar panels. So we understand that that is a social problem. Oh, in our place, there are legal grants that you cannot do anything like this. You want to account for everything here. Do we understand? Do we understand? Yes. Okay, great. Thank you. Okay, so example of interested parties, stakeholders, and their concerns. Okay, so we can have, regulatory authorities. So when we talk about regulatory authorities, there may be a lot of them. For example, in Nigeria now we have NEC, that regulate electricity. Am I correct? And then we have other regulatory bodies like that may probably affect what you are doing. Oh, they have regulatory that is supporting. They have regulatory that is against this thing I want to do. Oh, staffs, their expectation is, we also need to reduce because our company is about to close down. No, but if we can cut costs, you understand their needs. I don't know if you understand what I'm saying. So it cuts across customers, clients, energy suppliers, and a lot of other. You shall know every stakeholder that you know that will be responsible in one way or the other to the consumption. So you have them here. Do we understand? Okay. The fifth tab. Oh, we want to check if there are legal and other requirements. Now, you want to be more explicit about the legal. Like, what category does it fall to? What I want to do. Is it corporate? Is it for a person? Is it for individual? Is it for you have to put it here. Okay, is it relevant? Okay, what is affected by this requirement? You want to state it. What action is required? Who is responsible? The required date. How often will this be reviewed? You want to know does it require further actions? You have to just take, depending on the situation where you find yourself. Okay, is that fine? Okay, so the sixth tab, what we have this, so we can have like risk and opportunities. Note on submission. So you want to analyze energy savings. You might make and demonstrate that they do not involve compromising any of these things. No, you may want to just prove that. So you want to know, okay, who is responsible for what? When will it be completed? If there is a risk along the path. This time, there is, let's say, there is a project that is going on now that will affect energy efficiency projects that you are talking about now. Is posing risk to what you want to do. Okay? Well, they get quiet. I'm thinking. This one that everybody is keeping quiet like this. I'm trying to think.
You see, it seems as if the hall is very, very quiet. Please, let's cast our mind back to auditing in the various industries. Who are the people that we attend to the auditor when they come? What are these people looking for? If you are in charge of diesel in the office and you have made away with some liters of diesel, they will call you to come and face auditor. Then why are we doing auditing itself? How important is it to the industry? Who are we going to call when the auditor arrives? These are the things that the man is trying to explain to us. Just cast your mind back to that kind of a thing. In the ministry and the agencies, when auditor is coming, the DG will call some people, come and receive these people. They will bring you from the department, come and explain what happened to this. That is exactly what he's trying to say. Please just cast your mind back to that.
Yes, thank you very much, sir. Sometimes I can be encouraged when you reply. So when you are not replying, I'm actually asking myself that, do they really understand what I'm saying? Are they angry with me? All right, okay, let's continue. So we go to C7. Business as usual, you want to understand like, okay, this is just like you set like a kind of boundary, the scope and boundaries. What are they doing? Energy audit for the whole facility. The ENMS is for the whole system. They just want to reduce
the energy consumption by its scope and the boundaries. They have
10 buildings. They only want to do 2 boundaries. Then you come, you explain, they want to include all buildings except the whole warehouse. Why? It is not occupied, whatever. If you have further note, you had it. So then for scope and active, you should put everything here. So that's the scope. You have to define your scope and the source, energy sources. They are using electricity. Now, in case, now look at this now, they don't have electricity in this facility. Like they don't have significant, like there is no comment on the electricity issue, the source. So they put not available. If you don't have electricity, or let me say, no, we don't have bulk nitrogen, bulk liquid nitrogen, for example. You can put, this is not available here. Do we understand? Do we understand? Yeah. Okay, so then we can also make some further comments as the situation may demand here. Okay, so the C8, we want to know who's responsible for who. Because sometimes when you just give instruction generally, it's keep hanging in the air. Nobody takes it serious. So in the facility, and this will actually involve the top management guys too. So they will delegate tasks. What are the kind of job titles that you can have? You can have as the managing director, the energy team chair, the energy, the maintenance, the production project, and so on and so forth. So How do you now do this? So you will now pick from, let's say, in the context now, you want to know, okay, is it an external context like this PESU analysis? Who is responsible? Is it the managing director? Is it the energy team? Is it the energy manager? Is it the maintenance? Do we understand? Do we understand? Some people are sleeping. Good morning to those that are sleeping. All right, so don't worry, we are going to where the energy is. Maybe at the place of energy, you will you pay more attention because it will relate to you more directly there than all these analyses, these political, these you know. Okay, so then the interested parties, who and who will be responsible. Then you want to ensure resources are available. Who will be responsible to that, and so on and so forth. So this for this. So you can have the code here. R is for responsible. A is for accountable. S is for support. C is consulted. I is informed. Oh, in this case, the managing director is informed. I put I. In this case, the energy team will be responsible. I put R. Do we understand? So that's how it goes. Okay, so if you have energy management appointments, like you can copy anything like documents that can actually be of help to support what you have put here. You can add it to this sheet. So okay, then the next is energy team managers. You want to who are the energy managers and how do they meet? Oh, the first person. Okay, let's say here we have. Let me use a name. Let's use the name that we are familiar with. Okay, so the first person. Let's say the name is Daniel Ogunlana. Don't worry, I will try to go through the languages. You will be the one giving me names now. So let's say this one is our ND. Okay. Okay. Now let's have another name. Name? Emeka. 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 Emeka what? Emeka Ofo. You want to deal with Emeka Ofo, don't catch you. Emeka Abdullahi. That's a bad combination. Okay. Please try to correct me in case I'm not correct. Right? Okay, what position do we give him? What position? Energy manager. So let's say we have energy manager. Okay, who again? Shegun Arinze. So what do we have? What's this position? Production manager. Okay, gender balance. Okay. Esther what? Okafor. I think I should get that. Okay. HR. Okay. Okay, let's stop here. Let's say these are the team of those that are supposed to be in this meeting. Okay, so this one is responsible. Okay, is to be informed. This guy is to be hold responsible. Abi? So this guy is to be. This guy is to be what again? Huh? Is to support production manager, right? So it's to support an HR. Then informed or support, right? Okay. So let's pick any. So let's say we pick informed. So Mr. Ogunlana was in the meeting of this day. Let's say I have another date here. Okay? So he was around here. I marked him present. Oh, he was not around here. This Emeka Abdullahi wasn't around, absent. Oh, Shegun Arinze was around, present. HR was not present. She will explain where she goes to. Okay, so that, accent, of course, right? So for this day, so for this other day, okay, let's say everybody you were present, so I have X, I have X, I have X, I have X. So that this is to give a kind of mindset when they are checking how much they comply. Oh, they meet because you are expected to be meeting occasionally to know about the energy management. Because what you don't know, you cannot do. Right? Okay, so we go to the next one. If there is any, if there is any energy policy in that facility, my company now, ABC company, is committed to continually, and there is a policy, maybe they place it somewhere. So you want to account for it that there is a policy. Okay, but in case, then you see the picture, you snap the picture, you can bring it here, just like this. Do we understand? So that's the place for this. So then the next one that we'll talk about is, let's see, this objective and energy targets. Oh, we want to reduce electricity consumption by 2% of 2017. That means 2017 is the baseline data. That is when energy management has not been implemented in their facility. That was what we can also call the business as usual. That is, if everything remained the same, that is how they will keep going. So, okay, now, we now want them to know that by what we are bringing in picture, we would make them save 2% of this by the end of 2021. This is a kind of example. So, who is responsible? The project manager, whatever else is responsible. Then the due date, December 2021 or December 2022. Do we understand? Okay, for details, we go to ER. So we are going to that ER tabs now. This is where we will need more of our mathematical skills, our engineering skills, our analytical skills, and so on and so forth. But they're not big deals anyway, just little part of them. The first ER, what do you have to do? Get to the facility. You want to know the energy, the process. Oh, you collect data, how you want to implement yours. You collect data and develop consumption trends. This may have you to use maybe Excel to just draw like a line diagram. And the line diagram would tell you this is what they consume. Do we understand? Or would you quickly do line diagram? Okay, because everybody's just keeping quiet. Okay. Hmm? Yeah, so data you need to, of course, you need to collect their energy consumption data. Like, for example, their NEPA bill, you want to know if they are using diesel, what the history of the diesel they've bought, how much they bought it, how much they pay for electricity, how much the electricity if they use gas, how much if they are not using all this alone. Let's say it's a facility where they use LPG gas for cooking. You want to get how much of LPG gas they use. Let's say in the facility they use kerosene, you are putting it here too. So you are getting all data of any energy source that they use in the facility. Do we understand? Now, the other type of data that you need to get is the area of the facility. Because there's something as we call energy use intensity. You know, energy use intensity is like how much of energy you consume in 1 meter squared, or how much of energy you use to produce 1 kg of your production. So if it is like offices, for example, that you are not producing anything, you use it per meter squared, kilowatt hour per meter squared. Total energy that you consume, you do it per year, not per day. But some instances you can also do per day. Let's say for hospitals, for example, some points you can use per day. But usually it is yearly kilowatt hour energy consumed per surface area, 1 square meter, or the total energy consumed for 1 ton of production. Do we understand? So you need all those data. So, and how you do that is when you get, because that's what will help you in the benchmarking. In this facility now, the area of their facility is 1,000 meters squared. They are consuming 10 megawatt hour per year. Another facility, the consumption is they have, let's say, lower surface area. Instead of 1,000, let's say they have 600 meters squared. Do you expect them to consume more than those that have 1,000? No, you expect them to consume less. So on a normal day, that would have been a metric for you to just check between two facilities. Oh, am I doing well in my facility? So if the energy that is using per square meter in his own facility, the one that is now smaller, is now bigger than the one that is also using for the 1,000, then you know something is wrong somewhere. That's an indicator. But it is not always a metric to know if they are energy efficient. Do you understand what I'm saying? It is not always a good metric. It just gives you an idea that, okay, they are consuming more energy here than here. But to now know if they are energy efficient, no, that may not be. And can anybody tell me why that may not be? Good, great. What are they producing? So at production, you will not use kilowatt hour per meter squared. So at production, you use kilowatt hour per kg or per ton. So if you are looking at that, then you'll be comparing kilowatt hour per ton. So now, back to the same question. Mm-hmm. Mm. Okay. Okay, sir. So I don't want us to mix two things together. If you are looking at production company, we are using kilowatt hour per kg. We are not using meter squared. If you are looking at offices, we are using kilowatt hour per meter squared because they are not producing anything.
Like that. When you talk of, if they have, the two facilities are using similar machines.
Okay.
That's when you can make that comparison. But they can have one machine with the same rating, but one machine is faster than the other.
Hmm.
Can produce more kilowatt hour. Yeah. Yeah. No. No.
Okay. Yeah. Mm-hmm. Very good. Very good. You see, the number of time that you spend can be a very strong factor. Now, there are some other things that I have not really talked about because they seem a bit complex. Is, this AC, for example, will not consume the same way all through the year. Do we agree? Why? Seasons. So there are some times that it will be cold inside. AC will not have to work like when everything is hot. So the room is already cold to a very good temperature. So you don't expect AC to consume the same electricity to consume during dry season when it is hot to when, let's say, we have Amatan, for example, when it is cold. Do we get that? Okay, good. So, all these things, they are metric. But sometimes we have facilities that keep working, but they are not really producing at the moment. Let's say the production that they are doing, let's say at that time they are doing a kind of production that the system is just like revolving, doing a kind of thing, but it's not giving output at the moment. So are we now saying because they don't have kilowatt that they are producing at that moment, then they are, the kilowatt and per ton will be zero now? it will be very hard for us to know the state of that facility when they are not producing and when energy is still working. The consumption is still there. So, there is a plant that assembles vehicle that we visit. So when we got there, we noticed that when they are working or when they are not working, all the machines that are doing all those things, they are always on. Now, you cannot compare that to another facility that probably they have mechanics on ground or mechanisms on ground that address those ones. Oh, they are not working, it's switch off. I don't know if you understand what I'm saying. So now, when you now look at it all together, you want to check their production. Oh, this one is more efficient. You can say, well, somehow you may look at it and it will be a good guess that they are efficient. But there are some times that it is not a good guess. Like, let me use office as an example. In an office, sometimes you have 10 people in an office. Sometimes you have 20 people in an office. When you're having 10 people in an office, even though it is still the same surface area, they will not consume electricity like when they have 20. Because that's when they will go to different rooms. This one will say, I want to stay in my room. That one will say, I want to stay in my room. And some will not even know that it is not good to put their AC at 16 degrees C, across the chain. So they consume more. So, but when it now comes to you knowing, how efficient a system is, like, are they energy efficient? What are the things that contribute to their consumption? Because sometimes the area of the land may not really contribute that much. Like he said the other, there are some people, they have small area, they do things that are more than people that have larger area, and so on and so forth. So the next thing is, what can we now do to know are they energy efficient? That's what will bring us to what is called the regression analysis. You see, that part of regression analysis is a part that is it demands a little bit of statistics knowledge. When you go to your scatter diagram, you get the equation of line of best fit. You get the equation of the line of best fit. That is what gives you the y equals to mx plus c. I'm still taking it gentle. All right, let's leave that for the moment. As we keep going, we'll see something like that again in the future. So you are to complete an energy balance and select SEUs. I spoke about SEUs yesterday. Energy balance is you want to know how energy comes into the system and where energy goes in the system. So if the energy coming into the system is equal to the energy that flows in the system, then you consider that as energy balance. You say the energy is balanced. So you must be able to attain for that. But the moment you cannot do that, let's say the energy that is coming in is more than what you can account for. Probably if maybe your assessment is wrong. If maybe your assessment is wrong, like let's say you have not been able to capture all those that are consuming energy in that facility, or there is theft. Do you understand? But if on the other side, the energy consuming devices that you are having consumes more than the energy that is coming in. So you know that something is wrong with your estimations. Because sometimes it's not every time that you measure. When there is no chances of measuring, you can estimate, you can calculate. And if there is no room for a calculation, let's say you cannot measure and you cannot calculate, then you can estimate. Do we get that? Yes. It allows you for you to estimate because it is not really about the precision of the figure in this calculation. Because if I say you consume 5 kilowatts hours a day, I cannot tell you that even if you apply the same condition tomorrow, you may not consume that same 5 kilowatt hours. So it's not really about the precision, it's about having the idea of what the consumption looks like. Am I communicating? Yeah. So, and then don't forget understanding the significant energy uses. Like I said yesterday, we get into the house. What the significant energy uses?
when iron may not be in some situations. And in some situations, iron is there and it is under the bones. Do you understand? Yeah. So identifying your significant energy uses will help a lot. Okay? So that's about that. So don't forget, you have to understand the process. The process of what they do in the facility. You have to draw the diagram, the flow diagram, how it flows in the facility. I will show you when the slide comes up. So then you want to know where are you having waste. So when you want to have the energy flow diagram, you can actually now proceed with, oh, what next am I doing? Okay, let me now start measuring, let's start capturing and so forth. Alright. Don't worry about it. Just do that.
Yeah, let me zoom. Okay. So, okay. I was here. So now you complete energy balance and you want to know your you want to information developed, you want to develop your baseline. Now I was talking about baseline and the energy performance index. Now we'll still talk about that. You want to check people. You want to identify operational control. When we say operational control, it has to do with how do they put on their light when nobody is there? Do they put on fans that are working when nobody is there? The way their culture in that facility. So yes, then you want to like get your ESO list, like where are you doing your energy system optimization? Then you want to agree the target and action plan. Okay, so then there are some things you need to know, but you know we'll put them into practice as we go. So this is like a system. This is for like a crushing site where they crush a lot of things. They do a lot of. So look at the process. You can have this kind of diagram in your own facility too, to show their process overview. Do you understand? Do we understand? Okay. All right. So here you have the energy source. This is now where you put in more values here. Okay, so here they use electricity. What do they use it for? They use it for blow molders. They use it for injection molders, compressors, lightings, HVACs, waters, whatever they use it for. You state it here. What unit are you recording your data? Oh, it's in kilowatt. If it's not in kilowatt hour, you can change it to. If it's in joules, it's in whatever. But for your best interest or to your best interest, you want to do it in kilowatt hour because that is the electrical equivalent of your energy. When you put it in joule, for example, it still gives the impression that you are talking about mechanical energies. So, and most of the analysis that we'll be doing, we'll be doing it in kilowatt hour. So then the units that they use, for of electricity, this the amount of kilowatt hour that they use based on the year 2016. Oh, for coal, this is the amount of tons that they used. For natural gas, this is the cubic meter that they use, and so on and so forth. But in case you don't have this, it is fine. You can delete them, and you can add more if they have more than this. Do we understand? So then you want to know the percentage of, what is the percentage of this? But the one good thing about it is that the moment you fill in your values here, all these ones will be populated themselves. No, the ones here. What do I mean? Let's say, for example, now, you see this is 3 million, whatever, right? So please watch all through this place. You see as the value change. So if I change this to 1,000, for example, and check all these charts too, you see that they will change immediately. So, and you just click outside. You see that there is overall change all through. This one is now 3,600. This one is 1,000. This percentage is so small. Do you get what I'm saying? And all these ones, you see, this red is now very big. The natural gas is now very big. That they are not using electricity at all. Do we get that? So let's say it's a site where they don't have electricity. They are more on diesel or whatever. So this will give you further information about them. Then you can also know the amount of CO2 equivalent. So what do I mean by CO2 equivalent? CO2 equivalent is in emission, you can have a lot of different gases that are emitted. So there is a kind of calculation that you do to now know what is the amount of that emission in CO2 equivalent. So you now calculate it, but this already has been done. You don't have to be thinking about how to do the calculation. All what you need to do is just input your value here and you see changes. Is that fine? Okay. So that's about this. So let's go to the next tab. So in this tab here, there is a lot of calculation that you can do here. So now what do I mean? Now, let's say you have gotten to your facility, you get the kilowatt hour per month. This is it, you put it here. Then the next thing, you get the cost per month, you put it here. Am I communicating? So the moment you do this, then you put this guy also there, you put it, this guy is also there. Now, what is the essence of this? We have counted that, okay, for electricity, this is the amount of kilowatt hour they got from electricity. For HFO, this is the amount of kilowatt hour they get from it, and this is the amount of money they get from it. If they have other fuel you can have than gas, it's good. Okay, so the next thing is we'll go to the next ER. Now we are now dealing with figures more now. So here, there is a lot of analysis here anyway. So what I'm saying is here, what you do is that this is a kilowatt hour. We don't have fully for 2016. It started December 2016, right? So we have January to December 2017 data, kilowatts. Then we have the costs. Good. Now, this unit value was gotten by dividing this guy by this guy. Do you understand? What I mean is, if I put equals, if I say this guy divided by this guy, so it shows the tariff is 56 naira. Do you understand? Okay. So when you are doing it, you may also try to check what is the tariff that they use for their facilities. And these ones, you get them from the data that you have collected, the energy data. Because you cannot measure all these years' data before you can do the analysis. You are not expected to do that. Do you understand? Okay, so then to the ER4, so you have all these ones have been calculated actually, because if you put your cursor there, you see it gives you some value from C6 to C17. So from ER3 is summing everything up for this month, for December for you, and this it continues for the rest of the month, right? So this, am I communicating? Excel Abi. The Excel is appearing complex, Abi. I understand very well because
Okay, let me explain that. On this project, there is training for auditors and lead auditor. This one is supposed to be basic. And sometimes last year, I think SON, Standards Organization of Nigeria, carried out a training in Abuja here. You may not be there because they we are given that mandate to select those companies and expert base that they have been dealing with before. But this one is going to come up during the auditor and lead auditors training, just to give you the overview.
Now you are getting used to it. Like at least you are seeing it for the first
There
time.
is nothing bad if you know this one before that, but we
So-
shouldn't waste our time on this. Just know what it's all about.
All right. So with this now, the moment you do this, the target for 5%, if you are removing 5% from it, from all this consumption that you have in here, you have this. That's just a way to understand how it works. So when you come here, you can see table of the analysis, the kilowatt hour per month. So as an auditor, you may come here and say, why do they have this high consumption here? You want to know when they have the list. So what caused this? Is it that they didn't come to office, or probably they were energy conscious at this time? Do you understand what I'm saying? So I want to know if they are energy conscious here. Maybe that's why they're having this lower consumption. If they are here, they are just relaxed or something. Or let's say it is because of the time of the month. But don't give reason for them. Don't assume for them. Let them tell you that, oh, at this point, this is what happens. Do we understand? Okay, so don't let us stay much here then, so that it's not keep looking like magic. Okay, so we have electricity here. So this is how it goes now. So this can be like the SCUs now. So for the SCUs, you have building cooling. In this case, you have building cooling, and this is what the kilowatt hour per year is. So I wanted to talk a little bit about how you can get your kilowatt hour per year. And one thing I want to say here is that you just need some little mathematics. For example, like what I was explaining the other time. Let's say this 10 watt bulb. Right? You can say, okay, 10 watt bulb, how many hours is it operating per day? You multiply it. How many bulbs altogether? You understand, multiply the bulb. Then, you know, how many days of the week do they work? Oh, they work 5 days in a week, multiplied by 5. Am I still communicating? How many weeks in the year do they work? Oh, they have 1 week that they don't come to work at all. That's 51 weeks. You multiply everything together, you get their annual energy consumption. That's the way. Another way is, okay, you are there, you measured their consumption. And when you measure their consumption, your logger will give you the kilowatt hour. Then you don't have to be calculating what your kilowatt hour is. So you just take your kilowatt hour per day. You can multiply it either by the number of operating days, if you are given. If you know the number of they do that for 250 days in a year. That's when they work. Multiply by 250. If it is, you have to get the daily, you have to multiply by week, you follow that route too. I don't believe that is hard, right? Is it hard? But it's just keeping quiet. Don't worry, I also keep quiet soon.
All right. So now with this, you can come up with the overall usage and what's the process. Okay, here they have compressed air. Let's say they have compressors. So this is what is consuming. It's consuming 5,000 kilowatts hour per annum. Oh, they have lighting. See bulb here. Lighting, just bulb. Look at what is consuming. Now let me now give you some. You know that in some facilities that they already have good, at least good glasses at building everything. They have good glasses that if sun reflects on the glass, it will not come in, but light will come in. So that kind of window, if you're having such like this there, you don't need to always close the blinds. The time you put off the blinds, switch off the lights, becomes a saving for your passengers. Just imagine if you can only do that for, let's say, 10% of this consumption. This is what they consume per year. So if you do this for 10%, it means in a year you'll be able to save 300 kilowatt hour. My communication. Yeah. So let's say they are on band A and you are able to save them 300 kilowatt hour. So what if they have the 300 multiplied by 221? Can we do that mathematics? 300 multiplied by 300. This is 300, I mean, just on lighting. Just on lighting. So imagine you have so many, and I just use 10%. It may not necessarily be 10% because when there is sun during the day, you may be having like more than 3-4 hours of such. So that may be up to like 40% or more. So at long run, when you now look at what savings you can have, it will make a lot of savings. Yeah. Am I communicating here? Yes. Okay. So then that's for this. Maybe for production, also the process control. Maybe they need automated system. Because if let's say you want to go and reduce the speed to 2-1 based on the demand, yeah, there's tendency you sleep over at some point. The then you keep working at full speed when you're supposed to have reduced it. Human error. But when you have an automated system, it senses the demand and reduces the speed. That speed that you reduce at that moment is very good. Especially when you are dealing with fans. I will tell you something. You see, when you reduce the speed of fan by half, you will save 7/8 of your consumption. Yeah. All right. So you imagine how significant this would be. So the relationship actually is what we call affinity rule. An affinity rule. The relationship between power consumption and the speed is like raised to power 3. Am I communicating? Yeah. So if I say, for example, I reduce my speed by half, 1/3. So I have 1/2 or raised to power 3. That gives me 1/8. That will be the next consumption. 1/8 of what they use. I don't know if you understand what I'm saying. Yeah. So if you now pick that 1/8, you now remove it from the total consumption, you have 7/8. That's your savings that you have. It's too abstract. No, it's not. You're getting great. Nice.
So you say it's fan affinity what?
Fan affinity rule, yes. So we have it for fan, we have it for compressors. Yes. So that when you have that kind of flow interaction between power and speed, it's like that. Okay, so we'll still see some parts where we just have a little touch of that too. So then this kind of table will actually come out like this. What you have in here, you have these charts and what you have you. Okay. Then here can have this is a kind of what I was telling you. You see, this is the name, right? You are there, you pick the nameplate. This is the kilowatt, 20 kilowatts. This is the hours of operation in the year. How do they get it? 24 hours by 7 days multiplied by 50 divided by 2. So that means 24 hours by 7, that's a whole week, multiplied by 50, 2 weeks they are not working, and then they now divide that by 2. That means half of those time is when they work. Are we together? So, but this one is not necessarily that you can do the calculation there and put it there. Now, this is where I'm coming. Look at this exponent here. The exponent is 3 here, is 1 here. It's 3 here because we're having like pump, like fan, like this part. But like here now, you are not having, this is just hydraulic power drive. So you are having this power 1 because it is not fully dependent on the top of the machine that we are looking at like that. Like if you want to reduce the speed, you want to, I don't know if you understand what I'm saying. Okay, so let's continue. Then we have the process. We have the process 1, the kilowatt, this is how it goes to. Then for all these,
So how is light controlled? Switch on and off, you know. You may want to use photo sensor, occupancy sensor, and all other things. So then the heat users, for the significant heat users, there can be many ways to that. Okay, if you have a boiler in your facility, let's say for example, you use boiler, and you know it's producing heat for your water. You know, we have the feed water that comes into the boiler. Are we familiar with the process? Are we familiar with the process? Okay, we are not familiar because those who were answering we are not familiar. So boiler is like an electric kettle, right? So just imagine electric kettle that you have the inflow pipe that enters into the kettle, and the outflow that operates automatically, either with pump or something. It operates, water comes in, water goes out. So the water that comes in is what we call the feed water. Okay? So, I want to believe with me that the feed water that will be coming in will take the temperature of the environment. So let's say the environment is 30 degrees C, for example, and you want to heat the water to, let's say, 80 degrees C. So you have to cover the gap between that 30 and 80. That's the change in temperature. Abi? So that change in temperature is what will help us to quantify the amount of energy when you multiply it by specific heat capacity and by the mass. Am I communicating? That's a bit technical. That's a bit big. Okay, so now imagine instead of you starting from 30 to 80, you now have a kind of heat recovery from the exhaust of the pipe of the boiler, the exhaust, that flue. You now extract heat to come and pre-warm the water that is coming in. It now raises it from, let's say, 30 degrees to about 50. So you're now moving from 50 to 80. You know, you have saved a lot of energy through your waste energy. Hope we understand. Okay, great. I'm happy we understand. Okay, so sometimes we can have to extract like that. And there are even some cooling system like VAM, vapor absorption devices. What they do, that heat, you can go and use it to cause cooling again. Do we understand? I'm feeling like I'm talking to only one person or two persons here. Okay, let's go. All right, let's continue. Then you can have like this structure again. This structure gives you the SCUs. Like you want to know if it is SCU or not. So how do you know? You have put in your kilowatt hour, you have done this, and you know, you can always come up with, oh, it's part of the SCU, it's not part of the SCU. You can put it there. Just for accountability purpose. And then you have this graph that tells you you may want to look at it. Oh, outside lighting. You can imagine. We don't expect outside lighting to consume the highest. But you cannot just pick it because you just visit and you see light. It will not be easy for you to pick, right? But by measuring or by estimating, you know, the number of hours they put it on, it will help you to account for their consumption per day, which can make you to get for the year. Am I communicating? So, and then that makes us to know that, oh, outside lighting is containing more. So that may want to bring you to the mind of telling them that you can use photosensor. That when the photosensor senses light, it goes off. Maybe some people they forget to put it off when they are supposed to put it off, and it becomes problem. So that may be a saving something. So then we know, okay, the building, administration building, of course, we know here HVAC, ACs will take a lot. People don't want to feel heat and a lot of things. So it helps you to make your decisions from here. Do you understand? Okay. Then we talk about this process. At this process, you can also know the total heat used, the fuel efficiency, the generation efficiency. So let's say, for example, it's a generator that they are using. Am I communicating now? Generator efficiency varies based on load factor. Should I say that again? Load factor will contribute to how efficient your device is. If you load your generator to 25%, for example, of your device, it will be very inefficient. Am I communicating? But when you load your generator to about 60%, depending, if it is diesel, about 50%, about 60% is good. Are you getting me now? So if you load it to about 60%, what happens is it is more efficient than that time. If you take it higher, it will maintain the level of efficiency, but it will be overburdening the generator. I don't know if you understand. So now, for a facility, for example, in fact, through generator sizing, you can save a lot of fuel. You take the consumption, you know what the consumption is, then you size generator for them. Some people, for example, last December I was at a GTB site, and then they're looking for how to save energy. And then when I got there, we did the assessment. The average load that they have for every hour, average, was less than 100 kilowatts, like in kilowatts. And then they are using generator that is more than 350 kVA. I don't know if you understand that analysis. So the problem with that is, of course, they will be having electricity. They feel like, no, we have catered for every tough time, but the generator is wasting fuel. As it is at that 350 kVA, they can take it back to 200 kVA. If they downsize it, they will save significant amount of energy. There is also an analysis for that. But, just for you to have understanding that these are the ways that also make sense to make savings. Okay, so the moment you get with the generation efficiency here, it makes you know if they are efficient or not. Let's say you finish now, you now see that the efficiency here is 8 or 60%. Something is wrong. Am I communicating? And don't expect efficiency of generators to go to 100%. All right, do you understand? Okay, great. Then we have area, you want to put the area, okay, the data center, look at the energy consumption there per year, commercial buildings, they have 350,000, like 350 megawatt hour. It gives a lot of insight. And can they be switched off? If yes, look at this. In this situation now, the data center can be switched off at some time. I'm not sure. Maybe it can be switched off. You want to investigate. And it gives you a plan. This gives you a plan that next time when you're going through it, you know where you want to work on and all those things. So then you have the ER6. The ER6 is where you have where you do the data analysis skills. And with this, I will explain briefly. I will just try to explain to you. So you get this variable. When you get to site, let me use quick food service as an example. When you get there, they are producing rice, jollof rice, fried rice, chicken, ice cream, meat pie, and so on. You will get those variables because those are the things that they are using electricity to make, right? Then you will have, from the data they have given you, you know that this amount of rice they do, amount of this that they do, like the raw data they do, right? Do you get what I'm saying? Okay. So you now want to know with their energy history, are they related? That's a place of linear regression. Okay, let me say this. Let me put it here. So look at it now. I want to show you something. From January 2017 to December 2017. After you've done your linear regression, it looks like this. Okay? But now it is not really using. Now, when you are doing this analysis, probably you can pick a lot of variables, right? Let's say rice is there, jollof rice is there, whatever is there. So when you are doing your analysis, this regression analysis will show you variables that are correlated. It will let you know that because this is increasing, this also is increasing with this. How this is affecting this. Am I communicating? And why you know that, you'll be able to know that, in my facility, it is rice that is affecting me in the production. So you now come here, what is affecting you becomes the relevant variable. But when you get there, you get a lot of variable. Like occupancy of people, can that affect? You want to know. So that occupancy, it can be like maybe they have data of people that comes to office every day. You get that occupancy data. You want to know, okay, what else could be what could be affecting them here? You understand? Oh, there is what you call cooling degree days and heating degree days. In Nigeria, we use cooling degree days. So what happens is when you get the cooling degree days, it's an information. This weather data is available online. You can search it. Get cooling degree days. Most ACs they have that cooling degree days contribute to what affect in some instances. But in some instances, it may not even be the cooling degree day that is affecting it. It may be maybe because of the operation system. I don't know if you understand. For example, now, let's say this place is open, that place is open. So in this kind of data, this will tell you that the relationship between the variables that you have picked does not correlate. This is one of the things linear regression will do for you. So when you now get to linear regression, it will help you to even predict what energy they will consume when they are not producing anything. That's what I want to show you here. So you see this kind of equation here now. This y equals to 90 whatever x plus this. This is the intercept. The intercept means when x is not being done. So the variable that was relevant here was this x. Do you get what I'm saying? The variable that was relevant here is just this x. So maybe they have like 10 variables. If they have 10 variables that are relevant, you have y equals to 90.63 x1 plus 70 plus s2 plus till the 10 variables. It will now give you plus the intercept. That intercept is situations when all these factors are now affecting the consumption. What should we expect? So what we should expect now is that you have then it means when the variables area is not affected, like in this case, we have something like 90.63x. You still remember that? Plus a particular value. Do you remember? That value that I call intercept is what your kilowatt hour without the variables in place. Let's say here they produce water to here. They produce whatever they produce here. I've gotten amount of energy they used to produce. I've got amount of energy they used to produce malt. So the next thing is, how does this production affect my energy? So sometimes the one that will be significant is, let's say, the one that they are using to produce malt, for example, is what will now be more significant. Help you to pick that. Now, let's now say you have now picked all the variables that are now useful for you. The next thing will be that you will be able to predict when these variables are not coming out, what should your energy be? That is different from energy use index that I spoke about the other time, when you're having kilowatt hour per production. If the production is 0, you expect everything to be 0. You will not know the kilowatts that they will be able to get. Not even 0, because anything over 0 will give you infinity. Undefined, right? Great. So, but with this, you can still predict what amount of energy that they will use if there is no consumption. And that's the energy that you have in here. This one says something, 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 something. Do you understand? Okay. Okay. All right. Let's quickly see how we can quickly round up on this. So we have a lot of things to talk about here. How the conversion is to tons of CO2 emission, and then we have the ER7 here, where we have the difference between actual and expected consumptions that we have gotten. So this value that we got here before we know here we having expected, we have the electricity consumed. This expected is what the y equals to mx that we got the other time. We use it to predict what this expected should be. Do you get that? So now look at it, for example, when we now use that, this equation, we use this equation here, this equation here. Do you see this equation? That's what you use to predict this guy that you have here. So this is expected. This is their real consumption.
Thank you for the lecture. Actually wanted to ask a question about energy measurement. Is there a way you could measure the energy that a company or an organization or a room is consuming, even if the place is not metered?
Okay.
You understand?
I get your question.
Yeah.
Okay, so when you go to facility, you are not taking the measurement on their meter. You are going there with your own meter.
Okay.
So there are loggers and their meters you can use for that. And why are you not using their own meter? Sometimes their meter may not be accurate. So, and the need for doing meter accuracy for facilities. How do you know if maybe your meter is overreading and NEPA just come and they just give you bills? So it's still one of the ways that you can actually cut your costs, your savings in your facilities. Come again.
I said, how do you like connect all the energy consuming equipment to your meter to know how much consumption?
Okay, the process of connecting the meters.
Yeah.
Of course, yeah. During CPA, we will do the practical illustrations. You know, I showed you some loggers yesterday.
Yes.
So those loggers, they just attach them. Some they use CTs. Okay. CTs measures current. So like you don't have to have direct contact with the conductor. They measure. Then you have like some that have like that on the conductor part. That to the voltage. So, and when you have the current, you have the voltage. Some other things that may be very be of interest to you is like the phase angle between phases. When you're having like 3 phases, to get the power factor and a lot of other things. So we have equipment that does that, and in the phase of the CPA, of course, that will be catered for. Yeah. Energy manual. Yes. Okay, when you are implementing energy management, yes, of course. Yes. Yes. Any other question? Okay, thank you very much. With this, it will be a convenient place to stop. Thank you for your audience.
Something with waste will be there. That's why this course is very necessary to have engineers. So there's no cause for control. Everything is under alarm. So now we're supposed to ask questions, but questions are not coming. So just two questions. I agree with you, man. I agree with you. We're supposed to go for tea break now, and when we come back, we give this into the next presenter, which is on ISO 14000 series, and it has to do with environmental management. So we have less than 30 minutes.